Hi everyone, I'm Robin with IMGS and I wanted to give a very basic introduction to some spatial joins in FME. There are four different types of spatial joins in FME. We have our proximity joins, which are joins based on how far one feature is from another. So that would be transformers such as your neighbor finder in FME. The second spatial join type is a modifying geometry join. And that's joins that will cause the geometry to be changed. So if you're doing something like a cookie cutter type of spatial join, so transformers like that would be something like your clipper in FME. The third spatial join type would be the geometry relationship join. And that joins features based on the relationship between them. So whether the feature is inside, outside, or has a kind of a boundary touching another feature in FME. So a transformer that would do something like that would be your spatial filter. And then the fourth type of spatial join is an external join. So that's where you'd have data inside in your workbench and you would carry out a spatial join with data that is not in your FME workbench, so is external to it. And a transformer that would do something like that would be your feature reader. So I have a few examples of these in a workbench over here. And immediately on the left side, if we just look at the data types that we have, so we have some point data that was read in, some line data, and some polygon data. Now the point data, we've removed all the other attributes just to show our point ID to help identify it later on in the workflows. Then we have our line data as well with a line ID, and we also have polygon data with a polygon ID. And we have that filtered to just one polygon at the moment, just one area for the purposes of the spatial joins. So looking at the proximity type of spatial join, and we have our neighbor finder up here. So that could be something where you're looking for, let's say, the nearest bus stop to a road or something like that. And you'd configure it where you'd have the base data being your lines or your roads in this example, and the candidate data would be the points or the bus stops in this example. And if we click in here, you have your inputs, which are bases and candidates, or you can set that to candidates only, where you're just comparing features against themselves. And then you can choose candidates first, yes or no. But where the real configuration comes in is down here where you've got your number of neighbours defined. So you can leave that blank or you can set a total number of neighbours. Let's say you only want to find the top 5 closest bus stops to certain road segments. And you can also define a maximum distance. So we have 50 here and the unit of measurement is taken from the coordinate system or the projection system that the data is in. So because my data is in Irish Transverse Mercator, the 50 will be 50 metres. And we've other data settings that you can set and with regards to your Z values, how to treat polygons. But what's also important down here is your attribute accumulation. So you can merge the attributes together and you can merge the candidates to the base features. You can prefix the candidate or you can replace with a single candidate. So if you wanted the road information and the bus stop information, anything that kind of satisfied the above kind of criteria, then you'd have merge candidate and you could have all of those attributes being brought out in the output. And then in the case where you might have the same data schema in both data sets, or if you're using your just candidates only option up here, the conflict resolution would be use base or use candidate, depending on how you want to handle attributes that are the same. You can also generate a list and you can choose whether you want to have all of your attributes go out into that list or just selected attributes. So if you click OK, then we can see that based on the above criteria that we put in, that 3,133 points or bus stops were within 50 metres of a road. And we can see the outputs here. You have the line ID and then the point ID, then the distance between those. So all of these will be within 50 meters. And then you get angles, closest X, Y coordinates, that type of thing. And you can carry on in your workflow using these data fields as needed. The second spatial join type then is the modify geometry example. So that is where you're kind of cookie cuttering your data. So we have a clipper here, and it could be something where you want to clip roads to within a polygon boundary. So here we have the clipper, which is our polygon area. And then we have the candidate, which are the features to be clipped, and those would be the lines. And for this example, we'll say that they're roads. So if we go into the settings here, you can choose multiple clippers, whether the clippers arrive first, you can configure that. And what's also quite important to configure here is candidates on the clipper boundary. So if you had a line segment that was on the boundary of the polygon, you can choose how you want to handle that. Do you want it to be inside or kind of considered as inside the polygon, outside the polygon, or both? And then invalid parts handling. You also have Z value configurations, different measures, that type of thing, vector, raster. And again, we see our attribute accumulation. So similar to the previous transformer, you can merge the attributes together. And then conflict resolution is to use the candidate here. So if I go into this output, there were 1,564 line features that were inside the area of interest, the polygon. And the kind of spatial preview here is still loading, but we can see we've got our polygon ID. That will be one because it's the one polygon, so all of these will have the same polygon ID, and all the different line features that were within that area of interest. And what's important here as well, and which is quite helpful, is we can filter based on this clipped. So a record that has clipped set to no, and we can see when we clicked on it, it highlighted up here. That was a feature that was deemed to be fully inside the polygon, so the geometry was not altered. And then records where clipped is equal to yes, the geometry was altered, and that would be a feature that would be on the perimeter of this area. So we can filter those. You could put it into a test filter and identify those more clearly. And it's quite a useful way to join your data. And then the third example that we have is the relationship of geometries. So if you wanted to determine the spatial relationship between bus stops in an area, you could use a spatial filter. And the filter again will be the polygon in this case, and the candidate are our bus stops, our point features. You can carry out group processing in here, and you can choose different spatial tests to carry out. So in this case, we'd selected filter is OGC disjoint from candidate. So that is where the points are not within the area. So they're away from, there's no overlap. There are other different spatial queries that you can carry out. You can also carry out multiple at the same time, so it's not limited to just one test. You could set multiple here. And then similarly with your merge attributes, you can merge them on output, or you don't have to either. You could also just prefix the filter or only use the filter as the output attributes. And you can use candidate or use the filter for conflict resolution. So that kind of merge attributes or attribute accumulation comes up in all of these spatial join transformers. And we can see here that 5,228 points are outside of this area of interest, this polygon, and where it failed. So that's where points would be within that area. So it's 254 are within that area. And then the final join type is an external join, and that is where you can use a spatial filter kind of in your feature reader to carry out a spatial join in data when bringing it into the workspace. So we have the polygon here, our area of interest, and if we go into the feature reader, we're connected up to a database here, and then the spatial filter that we have set is the initiator intersects the result. So where the polygon data intersects the data set that we're attempting to read in from an external data source. And again, you can set any of these spatial filter types, but the intersect one is probably a very common one. And then what you need to set is the attribute and geometry handling, because it defaults to just read in the data features and not carry out a merge of the data features. So merge initiator and result. If we set that, then we're going to pull in the polygon ID from our spatial filter along with the data attributes of the data that we're reading in. And we can take a look at that here. So we have our external data IDs. And again, we just have one polygon. So polygon ID will be one in all of these cases. But the data that we read in is just specifically for this area of interest rather than reading in the full data set. So that's just a couple of examples of spatial joins in FME, just some basics to get you up and running. It's quite powerful. There's loads of different ways you can use these transformers. There's also a lot more transformers available to carry out spatial joins. And all of that can be seen on Safe Software's documentation and on FME Hub.